Hi everyone, this is Mrs. J, and today we're going to talk about extrema and end behavior of functions, and we'll also be sketching graphs and comparing different functions. I have a quick warm-up for you guys, so please pause the video and give it a try. All right, go ahead and check your answers here. So remember, the definition of an even function is that f of negative x equals f of x, meaning plugging in the opposite x value gives you the same y value. So notice 3 became negative 3, but my y value stayed the same. The definition of an odd function is f of negative x equals negative f of x, meaning if you plug in the opposite x value, you get the opposite y value. So both became opposite. If you think about what symmetric about the x-axis means, you'll see it's flipping from here to here. So the x value stays the same, but the y value becomes opposite. And then if it's symmetric about the y-axis, that's the same as being even. So you'll see here the y value stays the same, but the x value becomes opposite. So the first thing we're going to talk about today is what are called extrema of functions. So those are essentially the different maximums and or minimums of functions. We call them extrema. So a maximum, if you just see maximum, it's considered to be the absolute highest point. Sometimes it's also called the absolute maximum. Now, sometimes there is an absolute maximum, sometimes there's not, because your graph will continue infinitely up. So again, if it exists, you'll find the coordinate that represents the absolute highest point. Same for minimum, you find the coordinate that represents the absolute lowest point on your graph if it exists. Now, we are also going to be looking for what are called relative maximums and minimums, which are not the absolute highest or lowest points, but they are the highest and lowest points in reference to nearby points. So it's saying that no other nearby point is higher and no other nearby point is lower. It's essentially maybe a hill or a valley somewhere in the middle of your graph that, again, is not the absolute highest or absolute lowest. It is important to note that relative maxes and mins cannot occur at an endpoint. I like to remember this by thinking, okay, if it's nearby points, it's points to the left and right. And if you're at an endpoint, there's not points on both sides that you can compare it to. So max and mins, like absolute max and mins, can occur at an endpoint, but relative maxes and mins cannot occur at an endpoint on a graph. And maximums will always occur. If you think about what a maximum looks like on a graph, it's something like this. So it's like the top of a hill, and that's always going to occur when a graph is changing from increasing to decreasing. So that's one thing we're going to be looking for. So notice here we are increasing, and then all of a sudden we're decreasing, and that will create that maximum. And minimums will occur when our graph is changing from decreasing to increasing. And again, this could be an absolute max or min or a relative max or min, depending on the graph. All right, let's look at this first example and see if we can determine all extrema that exist for this function. And again, we're just going to estimate where these points are. So first, we're going to look for the absolute lowest points on our graph. And we can see that the absolute lowest y value is actually here at -8. And there's actually two coordinates that have that low value. So in this case, there's actually two absolute mins. So that's going to be at -5, -8, and it looks like at 7, -8. And I know this one looks like it goes a little below, but let's just say it's at -8. But again, these are the absolute lowest points on the graph. Now you'll notice on the left and right side of our graph, we have these arrows indicating that it's going to continue going up infinitely. So in this case, there is no absolute maximum because, again, our graph will keep going up forever and ever. Now, for our relative maximum, you see that we do have a point right here where our graph is changing from increasing to decreasing. And if you kind of zoomed in, if I zoomed in right on this part of my graph, it looks like a maximum. In reference to nearby points, it is a high point. So this would be our this would be our relative maximum, and I'm just going to estimate. I'll just call this 2, 6. I know that's a little bit off, but we're just estimating. So that's the coordinate of this relative maximum. And then if you look, these are the only minimums, and those are the absolute minimums. So we'll say that there are no other relative minimums. So again, if you just see the word maximum or minimum, it should be the absolute maximum or minimum, and then relative maxes and mins are high or low points in reference to nearby other points, and again, they cannot occur at endpoints. All right, so now I have one for you to try on your own, and it's not shown on this graph, but let's assume there are little arrows on the ends of this graph. Pause the video and give it a try. All right, go ahead and check. So again, since our graph is going up forever on the right and down forever on the left, there is no maximum and there's no minimum, but there are relative maxes and mins. So you can see right here where we're changing from increasing to decreasing at 112, this would be a relative maximum. And then here where we're changing from decreasing to increasing at 4, approximately -15, that would be a relative minimum. All right, so now we're going to move on and we're going to start talking about what's called the end behavior of graphs of functions. So end behavior is essentially what your graph is doing way to the right or way to the left. And we say that as x approaches positive infinity, that's essentially saying to the right. And as x approaches negative infinity, which is essentially to the left. So what is your graph doing? Is it heading up? Is it heading down? Is it approaching a value? So first we need to look at the way we notate end behavior. So it is pretty specific. So here we always start with denoting which side we're working with. So if you're on the right side, we want to say as x approaches positive infinity. So we use x, we write a little arrow, and we write an infinity symbol. And please note that for positive infinity, sometimes you don't see a plus sign in front, sometimes you do. Both are fine, both are acceptable in my class, and they mean the same thing. So, sometimes you see the plus for positive infinity, sometimes you don't. But this essentially means moving to the right. So as x approaches positive infinity, and notice that's how we will read it, then we say f of x approaches, and then here we would either write positive infinity if it's going up, negative infinity if it's going down, or it could be a number if it's approaching a value. And then here, this would be the end behavior to the left. As x approaches negative infinity, here you do need the negative sign out front. F of x approaches, and then that's what you will fill in, again with either positive or negative infinity, or perhaps a value. All right, so let's give a couple of these a try. We're going to describe the end behavior of these two graphs. So let's start with this first one, and let's say as x approaches positive infinity, f of x approaches. So if I start tracing my graph heading towards the right, I can see that this arrow denotes that it's going to just keep going down forever. So that means f of x will approach negative infinity. And then as x approaches negative infinity, which essentially means moving to the left, so if I trace my graph to the left and I see where I'm headed, this arrow shows that we're just going to keep heading up forever. So I see that f of x will approach positive infinity. All right, let's look at this next one. So let's start as x approaches positive infinity, which is to the right. If you start tracing your graph, you'll see that our graph actually is flattening out. So it's actually approaching a value. Here we would have maybe what's called a horizontal asymptote. We'll talk about asymptotes later on in this school year, but it's essentially a value that your graph gets really close to as you go to the right or left. So you can see that our graph is approaching 2 as we progress to the right. So f of x approaches the number 2. So again, we can see that it's not just going up forever. It is flattening out and approaching a value. And then to the left, so as x approaches negative infinity, we can see that if we trace our graph to the left, it is going down forever. So that side will approach negative infinity. All right, I have one for you to try on your own, so please pause the video and give it a shot. All right, go ahead and check your work here. So for the first one, as x approaches positive infinity, f of x approaches positive infinity. And as x approaches negative infinity, f of x approaches negative 4. And then on the second graph, you can see that on both sides, to the right and left, our graph is heading down towards negative infinity. So you can write your end behavior separately, or if you have the same end behavior, you are more than welcome to write as x approaches plus or minus infinity, f of x approaches negative infinity. Either way is totally fine. So now that over the last 2 lessons, we've covered all these different key characteristics and ways of describing graphs, we're going to be working with some different characteristics to see if we can actually sketch a picture of what the graph might look like. So some key features to keep in mind, or information we might have about the graph. We'll talk about domain, which again are all of the x values that are defined, the range, which would be all the y values. Perhaps you'll have information about intercepts, which could be where it crosses the x or y axis. You might be told about the end behavior, so that would kind of help you decide what your graph is doing way to the right or way to the left. You may have information about the extrema, so you might have absolute maxes or mins, highs or low points, or you might be given relative maxes or mins. And then you also might be given information, this is a little bit new, about where your graph is increasing or decreasing. So your graph is increasing when it has a positive slope or it's moving up. And we always are going to read our graph from left to right, so it would be something like this. And it's decreasing when it has a negative slope or it's moving down. So you might be given information about that, or you might be asked to describe where your graph is increasing or decreasing. And this is always done in terms of an interval of x. And then you also might be asked to describe, or you might be given information about where your graph is positive or negative. If you're ever told that your graph is positive over a given interval, it just simply means that it is above the x-axis. So positive means above the x-axis, and if it's negative, that just simply means it is below the x-axis. And these intervals, again, will always be described in reference to the x values. So it's the interval of x values. All right, so now we're going to see if we can describe all of these different characteristics of this function. So let's start with our domain and range. And for this, let's just use interval notation. So I can see that my graph is going to the left and right forever. So my domain is all real numbers, negative infinity to positive infinity. And I can see that for my range, it is restricted. There's a low value, but it goes up forever. So it looks like it's from negative 4 to positive infinity. And I used a bracket to include negative 4 as part of our range. Now let's look for our x-intercepts, which is where it crosses our x-axis. There are 3 of them, negative 3, 2, and 5. And our y-intercept occurs at negative 2, where it crosses our y-axis. For end behavior, you'll notice that on the right and left, both sides are going up. So we can actually combine that into a single as x approaches positive or negative infinity, f of x approaches positive infinity, or if you'd like to write it as 2 separate end behaviors, that's completely fine as well. Now, positive and negative, that's one of the new ones we're going to talk about. So positive means that it, again, is above the x-axis. So we can see that that's occurring in 2 different regions, here and here. And we're going to describe this in terms of the intervals of x where it's above the x-axis. So I can see that from negative infinity up until negative 3, our graph is above the x-axis. So we'll say negative infinity to negative 3. And then I'll put this little union symbol. Sometimes you could also just use a comma in between. But we have another interval where our graph is above the x-axis. So that's from 5 and then infinitely to the right. So from 5 to positive infinity. Now, negative simply means that our graph is below the x-axis. So that's happening also, again, in 2 regions. I know it looks like 1 region, but here at 2, our graph is not below the x-axis. It is on the x-axis, so we don't want to include that. 0 is not negative. 0 is also not positive, so make sure it's not included in either interval. But here you can see that our graph is below the x-axis from negative 3 to 2. So that's our first interval. Notice I'm using all parentheses, so I'm not including the zeros. And then from 2 to 5, it is also below the x-axis, so considered negative. Now, increasing and decreasing is also a new one. We're going to describe them in terms, again, of the interval of x. And increasing just means you have a positive slope. So if you're reading from left to right, like you read a book, it means that your graph is going up. So I can see that our graph is increasing over the interval, well, from here to here. We'll just kind of estimate, let's just say this is -3/2. Again, we're estimating that interval. So -3/2 to 2. We could see that there's another interval where our graph is increasing, and that's right here. Our graph is going up, and I'll say that that's from approximately, we'll just say from 4 to infinity. So I'll do a little union symbol, and then 4 to infinity. And again, you could just simply put a comma in between as well. Now, decreasing means we have a negative slope, or it means that our graph is moving down. So I can see in this interval, our graph is moving down, and that's from -infinity up until what we call -3/2. So -infinity to -3/2. And this one I'll just separate with a comma just to show a different notation. We can see we have a second interval where it is decreasing. So from 2 to 4, our graph is decreasing. So make sure when you're looking at intervals of positive and negative, there should never be any overlap. And when you're looking at intervals of increasing and decreasing, there should also be no overlap. And they really should change off at those endpoints. And we're going to just use interval notation for this. It's always in terms of the interval of x. All right, now let's look for our absolute maxes or mins. Here, our graph is going up forever on both sides, so there is no absolute max. I'll put D and E, does not exist. But there is an absolute minimum right here, and we are going to name that coordinate. We're calling that x value -3/2. Again, we're just kind of approximating. So just be careful. This is an actual coordinate. I know that interval notation looks like coordinates, but these are intervals of x, and this minimum value is an actual coordinate. Now let's look to see if we have any relative maxes. I see right here I kind of have a top of a hill, and all the nearby points are lower, so this would be a relative max, and that point is at 2, 0. And then here we have like a little valley. Our graph is changing from decreasing to increasing. So we do have a minimum, a relative minimum here. I'll say that's at 4, -1. So here we were able to describe all of the key characteristics of this function. Again, I think the trickiest ones will be the positive, negative, and increasing, decreasing, because we need to describe them in terms of the interval of x, and that's not often very intuitive. So just be careful when you're working with those descriptors. All right, I have one for you to try on your own. So please pause the video and give it a shot. All right, go ahead and check your work. So domain is all real numbers. Range is restricted, so it looks -infinity to approximately 5. I just estimated. We do have 3 x-intercepts and 1 y-intercept. Our end behavior matches. As x approaches positive or negative infinity, f of x approaches negative infinity. Now for positive and negative, be careful. Again, it's in terms of the x interval. Our graph is only positive here from 2 to 4. Notice I'm not including when it's 0. And it's negative, be careful here. So watch out, especially for this area right here. We don't want to include where it's 0. So it's negative from negative infinity to -1, then -1 to 2, and then 4 to infinity. So make sure you're kind of splitting up this interval. For increasing, also a little bit tricky. It's increasing here, so from -1 to, or negative infinity to -1. And then you'll notice that it's increasing here from 0 to 2. It actually flattens out for a second. So I'm going to say it's going from negative infinity, or from 0 to 2, and then 2 to 7/2. I'm just approximating this. But notice I'm not including 2 because it looks like at this point it's flat. So it's neither increasing nor decreasing. So that part is definitely a little tricky as well. And then it is decreasing here from -1 to 0 in this interval. and then from 7/2 continuing on towards infinity. Our maximum is this coordinate, 7/2, 5. Our minimum, there's no absolute minimum because it's going down forever. And then this is our relative maximum at -1, 0, and this is our relative minimum at 0, -4. This is neither because it's not a low or a high point in reference to the points around it. So we should not include this as a relative max or min. All right, so here we're going to try to sketch a function that has these key features. There's more than one way we can graph these, but there's definitely some things that must be true about any graph. So we're going to talk about what these different features tell us. So first, it's telling us that we have a y-intercept at 0, -4. So that we can certainly plot on our graph. That is a certainty. I'm just going to put a point at 0, -4. The next thing it tells us is that our graph is decreasing from -infinity to +infinity, meaning over all real numbers. So our graph should always be going down as we move from left to right. So I'm not saying it needs to be a linear function. So maybe sometimes it's steeper, sometimes it's flatter, but it should always be moving down as we read from left to right. And it says that our graph is positive, meaning above the x-axis, from -infinity to -3. Again, that's the interval of x. So that tells us at -3, our graph is crossing the x-axis because it is no longer positive after -3. So this is kind of a tricky way of telling us that we have an x-intercept at -3, 0. Because again, if your graph ends being positive at -3, and this is the only time your graph is positive, that means it has to cross over and become negative. So we can plot this point. And again, as long as our graph is decreasing as we continue on, the exact kind of shape of your graph could differ, but I'll draw it maybe something like this. So maybe sometimes it gets steeper, sometimes it's flatter. That part is up to you, as long as you have these three things. So let's go through our checklist. We do have the correct x-intercept. It is decreasing throughout its entirety. So I can check that off. And it is only positive from -infinity to -3. And then after that, you can see it is negative. So that one is done as well. All right, so I have one for you to try on your own. So go ahead and pause the video and give it a shot. All right, go ahead and check your work here. So again, your graph might not look exactly the same as mine, but there are some things that your graph needs to have. So you do need to have the correct x-intercepts at -6 and 4. And since it says our graph is increasing from -3 to 4, that should be the only time your graph is increasing, which means it's decreasing from -infinity to -3 and from 4 to 0. Now, the y value of this minimum, it can be anything on this line that's below the x-axis. So that might look a little different. Maybe your graph goes way down here. Maybe it's much flatter, but it should be somewhere on the line x equals -3. And then your graph should touch and turn at 4 because it needs to be decreasing after this point, and it does cross over. It has an intercept here. So that should be your relative maximum on this graph. All right, here's one last try for you. So please pause the video and hit play when you're ready to check. All right, go ahead and check. Again, your graph might not look exactly the same as mine, but you should have a few key features. When we're saying that the range is -infinity to 7, it's kind of a way of saying, okay, our maximum, our absolute max is going to be somewhere at y equals 7. If our graph is negative in these intervals, that means it's positive in between, and it also means that it's crossing over. So it's kind of a sneaky way of telling us where our x-intercept should be. And if we're decreasing from 1 to infinity, that means that we're increasing up until that point. So this is how we should know that there is an absolute maximum here at 1, 7. So we know it is occurring at 7 because of the range, and we know it's at x equals 1 because of where it's changing from increasing to decreasing. So it doesn't need to look exactly the same as mine, but it should have those same key features to be considered correct. All right, that is all for today's video. Thank you so much for watching.